Hi, this is Alfozia Nihar from our home tuition. Welcome to our session today. The topic that we're going to discuss in our today's video is finding powers using De-Moiver's theorem. In this video, we are going to take a look at a really nice way of quickly computing the integer powers of complex numbers. We'll start with the integer power z. Z is equal to r e raised to I theta. This is very easy enough to calculate. If n is an integer, then this can be written as, we know the law of exponent, power over power. When there is a power over power or any term within a parenthesis, this is a power common for both the terms within the parenthesis. This will be applicable for r as well as e raised to I theta. So this can be written as, here for this term, e raised to I theta raised to n, this is a power over power. Am I right? If this is the case, we can just multiply the exponents. That is one of the law of indices. Actually, there is really not too much to do with the powers other than working a quick example. Let me show you an example and let's see how we are going to apply the De-Moiver's theorem in finding the powers of any complex number. Here is an example. This question asks us to compute 3 plus 3i raised to 5. We are supposed to find the power of this complex number. Of course, we could just do this by multiplying the number out. But this would be time consuming and sometimes there are many chances for mistake. So instead we can convert to exponential form and then we can quickly get the answer by applying the De-Moiver's theorem. Okay, so what would be the exponential form of this? Exponential form of 3 plus 3i would be, first we need to find the r as well as the theta. So this is going to be a square plus b square. So 3 square plus 3 square is 9 plus 9. So 18. That is going to be 3 root 3. 3 root 2. Okay, now theta. Theta is nothing but tan inverse of b over a. Or tan theta is nothing but b over a. So argument of the z is going to be pi over 4. So the complex number 3 plus 3i can be written as 3 square root of 2 e times I e raised to I pi over 4. So as a first step, we are just writing the complex number in the exponential form. Are you clear till this step? Now we are going to do the computation quickly. That is, we are going to compute the exponent. I'm just replacing this 3 plus 3i by the exponential form 3 root 2 e raised to I pi over 4. Now apply this power for each of the term within the parenthesis, for this constant and for this exponential term. As I already told you, I'm going to apply power over power here. That is, I'm just going to multiply the exponents. And if you're expanding this for 5 times, I'm getting 972 root 2. Please check whether you're getting the same value. Now you can just apply the De-Moiver's theorem here. E raised to I something can be written as cos of that term plus I sin that term. So I'm going to just rewrite this. Using the trigonometric ratios table, you can find the values for cos 5 pi over 4 and sin 5 pi over 4. For this one, I'm getting value 1 over root 2 or root 2 over 2. And for this one, the same value I'm getting, root 2 over 2. Please don't forget to mention this I. This is a negative value, both. If you are distributing 972 root 2 within the parenthesis, root 2 times root 2 will become 2 and 2 gets cancelled out. Same way even for this one. So if you are distributing, you will get, please make sure that you mention I without fail in your answer. Hope you're clear with this example. Okay, the trigonometric form of a complex number that provides a relatively quick and easy way to compute the products of the complex number. As a consequence, we will be able to quickly calculate the powers of the complex numbers. And also even the roots of the complex numbers can be found. We can discuss that in a separate video. Okay, now let me give you the theorem, De-Moiver's theorem. Okay, here is an example. Let z be r times cos theta plus I sin theta. Using the trigonometric form of z, show that z square is equal to r square cos 2 theta plus I sin 2 theta. The result of this one is not restricted to only squares of a complex number. If z is equal to r cos theta plus I sin theta, then it is also true for the cube. It is also true for the power raised to 4. I'll show you how. Z cube is nothing but z times z square. Am I right? So this can be written as in this form. So this can be written as z can be written in this way and z square is this. Just plug in. So you will get We have already discussed how to multiply two complex number in polar form in multiplication and division of polar form. For detailed video about the steps, you can view that video. So by multiplying these two, we will be involving trigonometric formulas also. Cos A plus B, sin A plus B formula. So by doing so, we will get, in multiplication of a polar form, we just multiply the r's and add the thetas. Same way, if we continue this pattern for z4, z raised to 4 is nothing but z square times z square. We are going to apply the same product rule. So even for z square, you just multiply z and z. You'll get this. Multiply this r and add the thetas. So it will be true for anything. So it will be true for z raised to n also. So let z equal to r cos theta plus I sin theta be a complex number and n be any integer. Then we can easily prove that z raised to n is equal to r raised to n times cos n theta plus I sin n theta. It turns out that De-Moiver's theorem also works for negative integer powers. Okay. Here is an example. An expression is given. 1 plus I raised to 5. Evaluate the above expression using the De-Moiver's theorem. Since De-Moiver's theorem applies to the complex numbers written in polar form. So we must first write this 1 plus I in the polar form. To find any number, to rewrite any complex number into polar form, we used to find r and theta. Am I right? R formula is square root of x square plus y square and theta formula is tan inverse of b over a or y over x. Both are same. So step 1 is to find the r. R formula is x square plus y square. You just add these squares and take the square root. So x is 1 and y is also positive 1. By plugging in the x and y values in this formula, we get the r value. Therefore, r value is nothing but square root of 2. Now next step, we have to find the theta. So let's use the theta formula. Here is the formula to find the theta, tan inverse of y over x. Y is 1 and x is also 1. Just plug in these two values in this formula and then you're going to look at the trigonometric ratios table to find the theta value. So for what value tan theta would be equal to 1? Yes, pi over 4. So theta is nothing but pi over 4. Now let us use the De-Moiver's theorem to evaluate the expression. First, let me write the De-Moiver's theorem. Here is the theorem. We have got the r and theta in the previous two steps. So just write whatever expression given in your question on the left side and plug in the r and theta. And we also know the n value from the given question itself. So plug in r, n, theta in the formula for the right side of the equation. Replace all r by square root of 2 and n by 5 and replace theta by pi over 4. Hope you're clear with this step. Now take the exponent square root of 2 raised to 5. That will give us 4 root 2 and within the parenthesis we'll get 5 pi over 4. By looking at the table or the unit circle, you can find the value for this one. For this one, I'm getting negative root 2 over 2. The same value that we got in the first example. And even for sin pi over 4, we'll get negative root 2 over 2. And again I repeat, please don't forget to mention this I. And please be careful with the signs given in your table values. Now you have to distribute this constant within each and every term within the parenthesis. So I'm getting 4 root 2 times root 2. That will give you 4 times 2. So 8. There is a negative sign already. So negative 8 over 2. Same way here, 4 root 2 times root 2 is 4 times 2. So 8 over 2. So the final answer is going to be negative 4 minus I times 4 or negative 4 minus 4i. Both are same. You have to give your answer in a plus bi form, the complex number form. Hope you're clear with this example and the steps. If you're doing this step by step, then it is going to be very, very simple and easy. So when you're dealing with integer powers of a complex number, they are just special cases of product. Please keep in mind that we will be using the same steps that we use in the product of a complex number. And the modulus of z, whatever expression you're getting, raised to n is the nth power of the modulus of that expression. And there are three cases. The z, whatever expression that you're getting, the modulus of z can be less than 1, greater than 1, and the absolute value raised to n is equal to 1. So we have to consider all of the three cases when you're dealing with integer powers of a complex numbers. The bigger n, the less the absolute value of z raised to n. Okay. While finding the theta, we will be using the trigonometric ratios table. So before solving the problems on this topic, have a glance over the trigonometric ratios table, or you can easily use a unit circle. So that will be very helpful for finding the theta, the argument. So that is all about the powers using De-Moiver's theorem. Hope you're clear with this concept. In case if you get any query regarding this, kindly let me know. See you in the